Welcome to Astronomy Daily once again. It's the 30th of September 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, Steve with you again, all the way from down under. And we have a nice collection of tales from the Astronomy Daily newsletter. Details on how to receive that in your email are coming up later in the episode, aren't they, Hallie?
We always say it. Every episode.
Well, that we do.
Today's newsletter has some interesting stories, including the discovery of a new sun in our night sky.
Well, that sure doesn't happen every day. A new sun.
A nova. You can read all about it.
Aha, yes. And there's another one about the progress of the Orion-spacecraft ready for the Artemis-3 mission, and more from the James-webb telescope, which has a report on early star formation.
All in the actual Astronomy Daily newsletter, but what have we chosen for our presentation today, my favorite human?
Well, Hallie, I'm glad you asked, because I found a story about the speed of the oncoming annular solar eclipse. Yes, the speed, which will sweep across the southern hemisphere on October 2, and also a story that has everyone talking, the little rock that will become Earth's temporary moon just for a little while.
That sounds weird.
Well, it is a bit weird, but that's why it's interesting.
A bit like you.
So what?
Weird and interesting.
Okay, that's good, I think.
I'm still trying to work out which bits are weird and which bits are interesting.
Oh, well, I'd like to think I'm mostly interesting. Being weird can be good unless you're in, like, a really important role.
Like mine?
Sure, Hallie, like yours. You can be as weird as you like.
I think I'll be, not weird at all, but completely interesting.
Well, you go right ahead and do that, Hallie. I don't think you'll get any complaints from around here.
I will.
So what's in your story file today, Hallie?
Oh, you might recall the hera-mission, which is a simulated mission to Mars.
Yes, I wondered what happened to that simulated mission. Did they get simulated lost in simulated space?
Again with the weird stuff. No, they did not. More on that later.
Okie dokie.
And did you hear SpaceX has grounded its Falcon fleet because of an engine mishap?
Yes, I want to hear all about that one. SpaceX news is always interesting news.
And not at all weird.
No, not at all.
But this one is a little weird.
Okay, hit me.
A new study explores why planets larger than Earth struggle to form in certain locations like low metallicity stars.
Yeah. That one is a bit weird.
I thought you'd like it.
And so while you're being so weirdless yourself and so interesting, would you also be so kind?
The short takes.
If you please, madam.
My pleasure, Mr. Weirdo. An all-volunteer crew on a simulated trip to Mars returned to Earth on September 23, 2024, after being isolated in a tiny habitat at Johnson Space Center in Houston. Their work is contributing to the science that will propel humanity to the Moon and eventually Mars. The Hera missions provide valuable scientific insights into how humans may respond to the confinement, demanding work-life conditions, and remote environments that astronauts may encounter on deep space missions. These insights help NASA prepare for humanity's next giant leap to the Moon and Mars. Campaign 7 Mission 3 started when Hera operations lead Ted Bobick rang the bell outside the habitat 10 times, a ceremonial send-off wishing the crew a safe and successful simulated mission to Mars. 7 rings honored the campaign, and 3 more signaled the mission, continuing a long-standing tradition. At Ingress, Anderson, a structural engineer at NASA's Langley Research Center in Virginia, told Hera's mission control, "We're going to take good care of this ship of yours on our journey." The Hera crew members participated in 18 human health and performance studies, 7 of which were led by scientists from outside the United States. These international studies are in collaboration with the United Arab Emirates Mohammed bin Rashid Space Center and the European Space Agency, ESA. Throughout the simulation, the crew performed a variety of tasks. They harvested plants from a hydroponic garden, grew shrimp, deployed a small cube satellite to simulate data gathering, conducted a virtual reality walk on the surface of Mars, and flew simulated drones on the Martian terrain. These activities are designed to immerse the crew in the task-focused mindset of astronauts. NASA scientists then monitor Hera crew to assess how routine tasks, along with isolation and confinement, impact behavior and performance. As their mission progressed, the team experienced longer communication delays with mission control, eventually reaching 5-minute lags. This simulates the challenges astronauts might face on Mars, where delays could be up to 20 minutes. Scientists studying Hera crew are interested to see how this particular group builds independent, autonomous workflows, despite this communication delay. As the mission neared its end, McCandless and Anderson participated in a ground link, a live session connecting them with middle school students in a classroom in Coconut Grove, Florida, and in Olathe, Kansas. Ground links provide a unique opportunity for students to engage directly with crew members and learn about the realities of long-duration missions. The students asked the crew about life inside the habitat, the challenges of isolation, and what it might be like to live on Mars. They were also curious about the crew's favorite foods and activities. McCandless shared her love for cheddar crisps and freeze-dried pad thai and proudly showed off favorite sports teams from her home state of Kansas, much to the cheers of the crowd. Anderson displayed the massive collection of comics and fantasy books that she read inside the habitat. In the late afternoon of September 23, 2024, the crew egressed from Hera, marking the end of their 45-day simulated mission to Mars. After stepping out of the habitat, the crew expressed gratitude for the opportunity and reflected on the mission's significance. Following our safe passage to Mars, and our safe return to Earth, as the crew of Campaign 7, Mission 3, we hereby officially transfer this exploration vessel to the Flight Analogs Operations Team, said Kent. We hope this vessel continues to serve as a safe home for future Hera crews. SpaceX's Falcon rocket fleet was grounded for the third time in 3 months after a second stage problem occurred Saturday following the successful launch of a Dragon capsule carrying 2 crew to the International Space Station. The suspension in flights comes as the company prepares to launch 2 solar system exploration missions in October with narrow launch windows. SpaceX said the Falcon 9 second stage that launched NASA's Crew 9 mission failed to correctly perform a firing of its Merlin vacuum engine less than 30 minutes after releasing Dragon Freedom into a planned orbit. The engine firing is designed to prevent the rocket body from becoming space debris by driving the stage into the atmosphere for a destructive re-entry. Any debris was supposed to fall harmlessly into the ocean in an area previously identified in warnings to mariners and aviators. Falcon 9's second stage was disposed in the ocean as planned, but experienced an off-nominal deorbit burn, SpaceX said in a social media post, shortly after midnight Eastern Daylight Time on Sunday. As a result, the second stage safely landed in the ocean, but outside of the targeted area. The mishap is likely to prompt an investigation from the Federal Aviation Administration, which oversees the company's launch licenses. SpaceX is currently in dispute with the FAA over fines related to Falcon 9 activities at Kennedy Space Center and delays in gaining authorization for the 5th test flight of its Starship vehicle from Starbase in Texas. Spaceflight now reached out to the FAA for comment but has not yet received a response, with the FAA's offices closed for the weekend. Debris from the rocket stage should have fallen in a stretch of the Pacific Ocean that started east of New Zealand, but probably ended up falling further downrange, but still south of the equator, according to Jonathan McDowell, an astrophysicist and tracker of space launches and satellites. The most likely failure mode that still results in re-entry is a slight underburn, he said in a post on X, formerly known as Twitter. So you expect the entry to be further along, but not by too much. McDowell told Spaceflight Now he estimates the deorbit burn should have occurred around 1:55 p.m. Eastern Daylight Time as the craft passed over Yemen. If everything had gone to plan, re-entry would have happened about 35 minutes later. SpaceX was scheduled to launch 20 satellites for OneWeb from its West Coast launch pad at Vandenberg Space Force Base late Sunday night local time, but that mission was put on hold, along with a Starlink delivery mission from Cape Canaveral originally planned for Wednesday. We will resume launching after we better understand the root cause of the problem, SpaceX said in its statement. This will be the third grounding of the Falcon 9 fleet in 3 months. An upper stage problem resulted in the loss of 20 Starlink satellites on July 11th. Flights resumed 15 days later after the company determined the cause of a liquid oxygen leak and came up with a quick fix. A shorter suspension of just 3 days came when a Falcon 9 first stage made a crash landing on the deck of SpaceX's drone ship after an otherwise successful launch on August 28. The company has not disclosed the cause of that mishap. The grounding of the Falcon fleet will be of particular concern to NASA and the European Space Agency, which had launches of solar system exploration missions planned within days of each other in early October. On October 7, a Falcon 9 is scheduled to launch from Cape Canaveral with ESA's hera-mission to study the Didymos binary asteroid system that was impacted by the DART mission in September 2022. Its launch window runs until October 27. Then on October 10, a Falcon Heavy, which uses the same second stage as the Falcon 9, is due to launch NASA's Europa Clipper on a mission to explore one of Jupiter's most intriguing moons. The Falcon Heavy will need all its performance for the $5 billion mission, and 2 burns of the rocket's second stage will be required. The spacecraft will be released from the rocket at a velocity of approximately 25,000 miles per hour, 40,200 kilometers per hour, the fastest speed ever achieved by a Falcon upper stage. The launch window for Europa Clipper closes on October 30th. A recent study by astronomers presents new evidence on the boundaries of planet formation, revealing that planets larger than Earth struggle to form around stars with low metallicity beyond a certain threshold. Using the Sun as a baseline, astronomers can measure when a star formed by determining its metallicity, or the level of heavy elements present within it. Metal-rich stars or nebulas formed relatively recently, while metal-poor objects were likely present during the early universe. Previous studies found a weak connection between metallicity rates and planet formation, noting that as a star's metallicity goes down, so, too, does planet formation for certain planet populations, like sub-Saturns or sub-Neptunes. Yet this work is the first to observe that under current theories, the formation of super-Earths near metal-poor stars becomes significantly more difficult, suggesting a strict cutoff for the conditions needed for one to form, said lead author Kirsten Boley, who recently received a PhD in astronomy at The Ohio State University. When stars cycle through life, they enrich the surrounding space until you have enough metals or iron to form planets, said Boley. But even for stars with lower metallicities, it was widely thought that the number of planets it could form would never reach 0. Other studies posited that planet formation in the Milky Way should begin when stars fall between -2.5 to -0.5 metallicity, but until now, that theory was left unproven. To test this prediction, the team developed and then searched a catalog of 10,000 of the most metal-poor stars observed by NASA's Transiting Exoplanet Survey satellite mission. If correct, extrapolating known trends to search for small, short-period planets around one region of 85,000 metal-poor stars would have led them to discover about 68 super-Earths. Surprisingly, researchers in this work detected none, said Boley. We essentially found a cliff where we expected to see a slow or a gradual slope that keeps going, she said. The expected occurrence rates do not match up at all. This cliff, which provides scientists with a time frame during which metallicity was too low for planets to form, extends to about half the age of the universe, meaning that super-Earths did not form early in its history. 7 billion years ago is probably the sweet spot where we begin to see a decent bit of super-Earth formation, Boley said. Moreover, as the majority of stars formed before that era have low metallicities and would have needed to wait until the Milky Way had been enriched by generations of dying stars to create the right conditions for planet formation, the results successfully propose an upper limit on the number and distribution of small planets in our galaxy. In a similar stellar type as our sample, we now know not to expect planet formation to be abundant once you pass a -0.5 metallicity region, said Boley. That's kind of striking because we actually have data to show that now. What's also striking is the study's implications for those searching for life beyond Earth, as having a more precise grasp on the intricacies of planet formation can supply scientists with detailed knowledge about where in the universe life might have flourished. You don't want to search areas where life wouldn't be conducive or in areas where you don't even think you're going to find a planet, Boley said. There's just a plethora of questions that you can ask if you know these things. Such inquiries could include determining if these exoplanets hold water, the size of their core, and if they've developed a strong magnetic field, all conditions conducive for generating life. Fortunately, future observations could be attained with the help of upcoming projects like NASA's Nancy Grace Roman Space Telescope and the European Space Agency's Plato mission, both of which will widen the search for terrestrial planets in habitable zones like our own. Those instruments will be really vital in terms of figuring out how many planets are out there and getting as many follow-up observations as we can, said Boley.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Affirmative.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at AstroDailyPod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Now, after the Great Northern Eclipse comes along the Ring of Fire Annular Solar Eclipse that can be seen in some iconic destinations. What is a Ring of Fire or annular eclipse? Well, the moon looks like it's taking a bigger and bigger bite out of the sun until it covers it, but not completely, leaving a ring of orange around it. A ring of fire can be seen in the Pacific Ocean or from the Pacific Ocean in South America, similar to the one witnessed in the US Southwest on October 14, 2023. But on October 2nd this year, an annular solar eclipse will pass over parts of the Pacific Ocean, southern Chile and southern Argentina. During this annular solar eclipse at the point of greatest eclipse in the Pacific, the moon will obscure 93% of the sun's center, creating a ring of fire effect, visible for 7 minutes and 25 seconds. And as I've reported on previous eclipses, during an annular solar eclipse, it is never safe to look directly at the sun without solar eclipse glasses specially designed for solar viewing. Ordinary sunglasses will not protect you. Coloured film or glass are likewise. Only prescribed viewing eyewear will suffice. So here's everything you need to know about the annular solar eclipse on October 2, 2024 in Chile and Argentina. The October 2 eclipse will be very similar to the annular solar eclipse in October 2023, which was visible across the US Southwest, Central America and South America. All solar eclipses occur when a new moon is positioned precisely between the Earth and the Sun and casts its shadow on the Earth. However, unlike a total solar eclipse, an annular solar eclipse occurs when the moon is slightly further from the Earth. So even when the disks align, from our perspective, the moon's shadow doesn't completely block out the sun's light. Instead, a ring of sunlight is visible around the moon. This eclipse will have a magnitude of 0.9326 according to eclipsewise.com. That means about 93% of the sun will be blocked out by the moon during the eclipse, resulting in an annulus, which is Latin for ring, and according to Moonlink, the moon will appear 6.4% smaller than average. The closer the observer is to the center line of the annular pathway, the more circular the ring of fire will be and the longer it will last. But experienced eclipse chasers often observe from the edge of the path during the annular solar eclipse to see extended views of Bailey's beads fizzing around where the limb of the moon touches or appears to touch the sun. They can be visible for several minutes, and it's quite spectacular. The ring of fire this time will be visible only within a path of annularity that passes across the Pacific Ocean, southern Chile and southern Argentina. Now this area will include the volcanic island of Rapa Nui, Easter Island as it's known, an iconic travel destination that's famous for the mysterious stone statues called moai, some of which reach 40 feet or 12 metres tall and weigh 75 tonnes. The island, which is only 63 square miles or 163 square kilometres, is located 2,300 miles or 3,700 kilometres from the Chilean coast, making it the most isolated inhabited landmass on Earth. Remarkably, it will be the second time a central solar eclipse has been visible from this tiny Pacific island in recent decades, with a total solar eclipse glimpsed there on July 11, 2010. The next total and annular eclipses there will be in 2324 and 2345 respectively. So how fast is this annularity ring of fire going to be? In each area you can expect this brief encounter with the conjunction on Rapa Nui Easter Island, Chile, 5 minutes 38 seconds to 6 minutes 12 seconds of annularity starting at 1403. At Cochrane, Chile, 5 minutes 40 seconds of annularity starting at 321, At Perito Moreno National Park, Argentina, 6 minutes 17 seconds, starting at 5:21. At Puerto Deseado, Argentina, 3 minutes 22 seconds of annularity, starting at 5:27. At Puerto San Julian, Argentina, 5 minutes 12 seconds of annularity, starting at 5:24. And for those who are very keen, yes, there are organised tours headed for Rapa Nui, Easter Island, especially to view the event. You've got to be very keen. But there is going to be some bad news attached to all of this wonderful news about eclipses. The chances of clouds that day are 75% for Rapa Nui, Easter Island, 90% for Perito Moreno National Park, 65 to 70% for locations on Argentina's Atlantic coast, according to time and date. On Rapa Nui, Easter Island, the cooling of the land could cause convective clouds to dissipate, according to Eclipsophile, with the south coast statistically slightly favoured. The chances of seeing the Ring of Fire are smallest, unfortunately, on Chile's Pacific coast and the highest on Argentina's Atlantic coast. The latter has the least interesting scenery, it says here, of anywhere on the path. Oh, how unfortunate. But the eclipse will arguably be more dramatic sight because it will occur much lower in the sky. That will be. And I do hope you get to see this wonderful event and capture some memorable images so that you can share them with us.
Astronomy Daily, the podcast. Astronomy, space and science.
Now, just in case you're the one person who hasn't heard yet, Earth is about to receive a visitor in the shape of a small asteroid which is going to orbit the Earth. It's going to become a mini-moon. This mini-moon is actually an asteroid about the size of a school bus, about 33 feet or 10 metres for the rest of the world. It is, when it whizzes by Earth on Sunday, it will temporarily be trapped by our planet's gravity and orbit the globe, but only for about 2 months. The space rock, which is glamorously called 2024 PT5, wonderful, was first spotted in August by astronomers at Complutense University of Madrid using a powerful telescope located in Sutherland, South Africa. These short-lived mini-moons are more common than we realise, said Richard Binzel, an astronomer at Massachusetts Institute of Technology. The last known one was detected in 2020. This happens with some frequency, but we rarely see them because they're very small and very hard to detect, he said. Only recently has our survey capability reached the point of spotting them routinely. The discovery by Carlos de la Fuentes Marcos and Raúl de la Fuentes Marcos was published by the American Astronomical Society. This one won't be visible to the naked eye or through amateur telescopes, but it can be observed with relatively large research-grade telescopes, Carlos de la Fuentes Marcos said in an email. Binzel, who was not involved in the research, said it's not clear whether the space rock originated as an asteroid or as a chunk of the moon that got blasted out. NASA defines moons as naturally formed bodies that orbit planets. Intuitively, we think of moons as big rocks that stick around for a while, like our very own moon. Astronomers have defined mini-moons as asteroids or comets that are gravitationally captured by a planet for a temporary amount of time. Small mini-moons are very common, but ones big enough to spot are very rare. 2024 PT5 is only the fifth ever detected mini-moon captured by Earth. A mini-moon is a temporary captured orbiter if it completes at least one full orbit of the Earth before returning to its usual orbit around the Sun. If a mini-moon is captured by Earth's gravity but doesn't make it around for a full orbit, it's temporarily captured flyby instead. 2 of Earth's mini-moons were temporarily captured orbiters, while the other 3, including 2024 PT5, fall into the temporary captured flyby category. Mini-moons are asteroids from the large population of near-Earth objects, or NEOs, that are temporarily grabbed from their orbit around the Sun. Near-Earth objects are defined as natural physical objects floating in space, such as asteroids, space rocks or comets, dirty space snowballs made of rock and ice that are orbiting the Sun and approach to within 1.3 times the Earth's distance from the Sun at some point in their orbit. Because these objects are around the same distance from the Sun as the Earth, they can sometimes be captured by Earth's gravity. 2024 PT5 and the previous mini-moon called 2022 NX1 were both captured from a group of asteroids orbiting the Sun at a similar distance from Earth called the Arjunas, which is one of the main characters of the Hindu epic Mahabharata. Please forgive my pronunciation again, I am Australian. The first known mini-moon was called 1991 VG. It arrived in late 1991 and left early in 1992. And like 2024 PT5, it was around 10 metres in diameter. In 2002, amateur astronomer Bill Yeong found what he thought was a second mini-moon, J002E3. Aren't they great at naming these things? However, on closer inspection, the object displayed a spectrum of light suggesting it was coated in white paint containing titanium oxide. Then a study of how the object's brightness changed over time found its shape resembled something like the upper stage of a rocket. Astronomers now believe J002E3 is the third stage of the Apollo Saturn V rocket, S03E167, instead of a natural mini-moon. The plot twist of J002E3, I think that's the third way I've read that number, made astronomers a bit more cautious when another mini-moon, 2006 RH120, was spotted on September 14, 2006, and it was first classified as artificial. However, after more observations, it turned out to be a natural mini-moon about 2 to 7 metres in diameter. In 2006, RH102 stuck around from July 2006 until July 2007. The new mini-moon will circle the globe for almost 57 days, but won't complete a full orbit on November 25. It will part ways with the Earth and continue its solo trajectory through the cosmos. It's expected to pass by again in 2055. Isn't that nice? And there you have it, another episode of Astronomy Daily. Thanks for staying with us today on Astronomy Daily. Please don't forget, Hallie's cousin Anna will be manning the studio from Tuesday to Saturday with more stories covering space science and astronomy. Isn't that right, Hallie?
She does a nice job. Very stylish.
I know, so you won't miss a thing. Hallie, where do you stream your episodes?
I get them direct. I'm an AI.
Oh, of course, that makes sense.
It goes with the territory. What are you using, human?
Oh, well, I like to use Spotify in the car. I get every episode, and it's true, I don't miss anything either.
Anna will be so pleased.
Yes, I know she is.
Nice.
So, folks, that's all we have until next Monday. So, bye for now.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.